Welcome to our deep dive into the interstellar hypothesis, a fascinating idea that stretches the boundaries of our understanding of the universe. This hypothesis suggests that life or even intelligent civilizations might not be unique to Earth or even our solar system. Instead, it proposes that life could travel between stars, carried by comets, asteroids, or even intentionally by advanced beings. Today we'll explore the origins, evidence, and implications of this bold theory. Let's begin by understanding what the interstellar hypothesis really means and why it has captured the imagination of scientists and dreamers alike. Roots of the interstellar hypothesis can be traced back to ancient times, when philosophers first wondered if life existed beyond Earth. However, it wasn't until the 20th century that scientists began to seriously consider the possibility that life could travel between the stars. The concept gained traction as our understanding of space, comets, and asteroids grew. The idea was further fueled by discoveries of extremophiles, organisms that can survive in the harshest environments on Earth, suggesting that life might be more resilient than previously thought. One of the most closely related ideas to the interstellar hypothesis is panspermia. This theory suggests that life exists throughout the universe and is distributed by meteoroids, asteroids, comets, and even spacecraft. While panspermia focuses on the spread of life within a solar system, the interstellar hypothesis takes it a step further, proposing that life can cross the vast distances between stars. Both theories challenge the notion that life originated only on Earth. How could life actually make the journey between stars? Scientists have proposed several mechanisms. One possibility is that microscopic life forms could hitch a ride on comets or asteroids ejected from their home planets by massive impacts. These space rocks could then travel for millions of years before landing on another planet. Alternatively, some have speculated that advanced civilizations might intentionally send life to other worlds, a concept known as directed panspermia. Journey between stars is incredibly harsh. Space is filled with radiation, extreme temperatures, and a vacuum that would destroy most forms of life. However, some microorganisms on Earth have shown an amazing ability to survive in extreme conditions, including the vacuum of space. These extremophiles give scientists hope that life could endure the long, perilous trip between stars, protected inside rocks or ice. Some of the most intriguing evidence for the interstellar hypothesis comes from meteorites found on Earth. Certain meteorites contain organic molecules, and a few even show structures that resemble fossilized bacteria. While this doesn't prove that life came from space, it does suggest that the building blocks of life are widespread in the cosmos, supporting the idea that life could travel between worlds. Comets are icy bodies that travel through the solar system and beyond. They are thought to be rich in organic compounds and water, two essential ingredients for life. Some scientists believe that comets could act as cosmic delivery vehicles, transporting life or its precursors from one star system to another. The discovery of complex molecules on comets supports this possibility. Asteroids, like comets, are potential carriers of life across the cosmos. Their rocky surfaces can shield microorganisms from radiation and extreme temperatures. Some asteroids have even been found to contain water and organic molecules, making them suitable vehicles for interstellar journeys. The study of asteroids continues to reveal new insights into their potential role in spreading life. Directed panspermia is a bold extension of the interstellar hypothesis. It suggests that advanced civilizations might intentionally send life to other planets, either to seed them with life or to ensure their own survival. This idea raises profound questions about our place in the universe and whether we might one day become the senders or recipients of such cosmic messages. While the idea of life traveling between stars is exciting, it faces enormous challenges. The distances involved are vast and the journey could take millions of years. Space is filled with dangers, from radiation to collisions with other objects. Despite these obstacles, the resilience of life on Earth gives hope that such journeys might be possible, at least in theory. Discovery of thousands of exoplanets, planets orbiting other stars, has revolutionized our understanding of the universe. Many of these worlds are located in the habitable zone, where conditions might be right for life. The interstellar hypothesis suggests that if life can travel between stars, some of these exoplanets could already be home to alien organisms. Extremophiles are organisms that thrive in conditions once thought impossible for life: boiling hot springs, deep ocean vents, and even radioactive waste. Their existence on Earth suggests that life could survive the harsh conditions of space and interstellar travel. Studying extremophiles helps scientists understand the limits of life and the potential for its spread across the cosmos. Astronomers have detected complex organic molecules in interstellar clouds, comets, and even on the surfaces of distant moons. These discoveries suggest that the ingredients for life are common throughout the universe. The presence of these molecules supports the idea that life could arise or be transported across vast distances. Water is essential for life as we know it, and its presence in comets, asteroids, and interstellar clouds is a key piece of evidence for the interstellar hypothesis. Water not only provides a medium for chemical reactions but also offers protection for microorganisms during long journeys through space. Interstellar dust grains are tiny particles that drift between the stars. Some scientists believe that these grains could carry organic molecules or even microorganisms, acting as microscopic vehicles for life. The study of interstellar dust is an exciting frontier in the search for evidence supporting the interstellar hypothesis. Stellar winds are streams of charged particles ejected from stars. These winds can propel dust, gas, and possibly even life-bearing particles across interstellar space. While the journey would be perilous, the possibility that stellar winds could help spread life adds another layer of intrigue to the interstellar hypothesis. Radiation in space is a double-edged sword. On one hand, it can destroy organic molecules and kill microorganisms. On the other, certain types of radiation can trigger chemical reactions that create complex molecules, possibly even the precursors to life. Understanding the role of radiation is crucial to evaluating the interstellar hypothesis. Fermi paradox asks a simple question: if life is common in the universe, why haven't we found evidence of it? The interstellar hypothesis offers one possible answer: perhaps life is out there, but it's rare, or it takes a long time to travel between stars. Alternatively, life might exist in forms we don't yet recognize. Search for extraterrestrial intelligence, or SETI, is an ongoing effort to detect signals from intelligent civilizations. If life can travel between stars, as the interstellar hypothesis suggests, then SETI's mission becomes even more important. Every signal we search for could be a clue to life's journey across the cosmos. If life exists elsewhere in the universe, what might it look like? The interstellar hypothesis suggests that life could be similar to what we know, or it could be entirely different, shaped by the unique conditions of distant worlds. This possibility inspires scientists and artists alike to imagine the endless forms that alien life might take. The Drake equation is a famous formula used to estimate the number of intelligent civilizations in our galaxy. The interstellar hypothesis adds a new dimension to this equation by suggesting that life could spread from one planet to another, increasing the chances of finding life elsewhere. Mars is one of the most studied planets in our solar system, and it serves as a test case for the interstellar hypothesis. Scientists have found evidence of water, organic molecules, and even possible signs of ancient life on Mars. If life once existed there, it raises the question of whether it originated on Mars or arrived from elsewhere. Europa and Enceladus, moons of Jupiter and Saturn, are believed to have subsurface oceans beneath their icy crusts. These environments could potentially harbor life, and if so, it might have arrived there via interstellar or interplanetary transfer. Future missions aim to explore these ocean worlds for signs of life. The chemistry of life is based on carbon, and organic molecules have been found throughout the universe. The study of organic chemistry in space helps scientists understand how life's building blocks form and whether they could survive the journey between stars. Supernovae are powerful explosions that scatter elements and molecules across the galaxy. Some scientists believe that these events could help distribute life or its building blocks over vast distances. The energy from supernovae might also trigger the formation of new stars and planets, setting the stage for life to emerge. Humanity has already launched probes like Voyager 1 and 2 into interstellar space. While these probes don't carry life, they demonstrate our ability to send objects beyond our solar system. In the future, we might send probes designed to search for or even transport life to distant worlds. Gravity plays a crucial role in the movement of objects through space. It can slingshot comets and asteroids out of their home systems, potentially sending them on interstellar journeys. Understanding the dynamics of gravity helps scientists model how life might travel between stars. Cosmic rays are high-energy particles that travel through space. While they can damage DNA, they can also cause mutations that drive evolution. If life travels between stars, exposure to cosmic rays could lead to new forms of life adapted to alien environments. Magnetic fields protect planets from harmful radiation and help guide charged particles through space. They could also play a role in shielding life during interstellar journeys. Studying magnetic fields helps scientists understand the challenges and possibilities of life's transfer between stars. Scientists have conducted experiments to test whether microorganisms can survive the conditions of space. Some bacteria and spores have survived months or even years outside the International Space Station, lending support to the idea that life could endure interstellar travel. Interstellar journeys could take millions of years. Over such long timescales, even rare events become possible. The vastness of time means that life could slowly spread from one star system to another, given enough opportunities and resilience. Chance plays a huge role in the interstellar hypothesis. The odds of a life-bearing rock landing on a habitable planet are incredibly small, but given enough time and enough opportunities, it could happen. This randomness is a key part of the theory's appeal and challenge. Advances in technology are making it possible to test the interstellar hypothesis in new ways. From powerful telescopes to space probes and laboratory experiments, technology is helping us search for evidence of life's journey across the stars. The search for life beyond Earth is a global effort. Scientists from around the world collaborate on missions, share data, and develop new theories. This spirit of teamwork is essential for advancing our understanding of the interstellar hypothesis and the universe itself. Curiosity drives the quest to understand our place in the universe. The interstellar hypothesis is a testament to human imagination and our desire to explore the unknown. Every discovery, no matter how small, brings us closer to answering the age-old question: are we alone? The interstellar hypothesis isn't just a scientific idea, it's also a philosophical one. It challenges us to think about life, existence, and our place in the cosmos. Philosophers and scientists alike ponder the implications of life traveling between stars, sparking debates that go beyond the laboratory. Imagination fuels scientific discovery. The interstellar hypothesis inspires us to dream of distant worlds, alien life, and the possibility that we are part of a vast, interconnected universe. Science fiction writers and artists have long explored these themes, helping to shape our collective vision of the cosmos. Observation is at the heart of science. Telescopes, satellites, and space missions allow us to gather data about distant worlds and the conditions that might support life. Every new observation brings us closer to understanding whether the interstellar hypothesis holds true. Education spreads knowledge and inspires the next generation of scientists and explorers. By learning about the interstellar hypothesis, students and the public can engage with some of the most profound questions in science and philosophy, fostering a sense of wonder and curiosity. Communication is essential for sharing discoveries and ideas. Scientists publish papers, give talks, and collaborate across borders. The story of the interstellar hypothesis is one of ongoing dialogue, debate, and the sharing of knowledge across the globe. Skepticism is a vital part of the scientific process. Not all scientists agree with the interstellar hypothesis, and healthy debate drives progress. By questioning assumptions and testing ideas, we move closer to the truth about life in the universe. Discovery is the reward for curiosity and hard work. Every new finding, from organic molecules in space to extremophiles on Earth, adds a piece to the puzzle. The interstellar hypothesis remains a tantalizing possibility, waiting for the next breakthrough. Hope drives us to explore and seek answers. The interstellar hypothesis offers hope that we are not alone, that life is resilient, and that the universe is full of possibilities. This hope inspires generations to look up at the stars and wonder what lies beyond. The future holds endless possibilities for the search for life beyond Earth. As technology advances and our understanding deepens, we may one day find definitive evidence that life can travel between stars. The interstellar hypothesis invites us to keep searching, keep questioning, and keep dreaming. In conclusion, the interstellar hypothesis challenges us to rethink our place in the universe. It suggests that life might be more widespread and resilient than we ever imagined. Whether or not we find proof in our lifetimes, the search itself enriches our understanding of the cosmos and our own existence. The journey continues and the stars await.